Hello everyone, here is going to be, whoops, we're going to have the notes of area of triangles with the proof of Heron's formula. So here we go. So we're going to start with the simple area. So the area, boom, I'm writing some here. I think that's going to be better. The area, and I'm going to use the letter K for area, just so we know all the way through when you're going to see K, you're going to know I mean area. So the area K of a triangle is K equals 1/2 the base times the height. And you know that from geometry, right? Where we're going to use B for the base and H for the height. So I'm going to rewrite that. I'm going to say K is equal to 1/2 B times H. So this will be the area of a triangle. Now let's prove that. Let's show why that is true. So let's just draw a triangle, and just any triangle will do. And I'm going to now extend my triangle. So this now became a rectangle, and I'm going to, in that rectangle, I'm actually going to draw my altitude for my triangle, right? Because this will be my height. But you notice that my height is always also that side, right? And then you notice that my base is going to be both sides of my rectangle there. But which side of my rectangles are alike? Well, this area is equal to this area, right? Notice how that's a rectangle, and I just have a diagonal who cuts it in two, so those two areas are congruent. And then area 3 is congruent to area 4. And if this is the case, we're going to say triangles 1 and 2 are equal in area. And we can see that because they form a rectangle, right? So obviously those two areas are going to be the same because it's a diagonal that separates them. And we can also say that triangles 3 and 4 are equal with the same thinking process in area. Therefore, the area of the triangle with base B and altitude H is exactly half of the area of the rectangle which is BH, right? B times h. So the area of the rectangle will be B base times the height, h, right? So it's length times width for a rectangle. For us, it's B times h here. So that will be the area of my rectangle. And then we can see that my triangle will be exactly half of that, right? Since area 1 and 2 are congruent and 3 and 4 are congruent. Okay, so that just proves the very basic formula of a triangle that we already knew, right? So we have that area already, that formula. So now let's see, what if we have a triangle? So we're going to say find area of a triangle in the format SAS, right? So we have two sides and the angle between them. Well, we're going to do a little sketch. It's always a good idea to do a little sketch. And this is my base. And then my altitude, I'm going to drop here. That's the height. And I'm going to say I have this angle C, and that will be my side A, right? Remember we said side, angle, side. So we need two sides and the angle between them. So that would match the little sketch I just drew. Okay? So now I'm going back to my trig functions, and I would know that sine of angle C has to be equal to opposite over hypotenuse. Well, the opposite will be h over the hypotenuse, which is a in my right triangle section there, right? And so now if I isolate h will be equal to multiply by a on both sides, and h will be equal to a sine of c. And we're going to hold on to that because we're going to use it to rewrite the area of a triangle using this for h now. So up here we just said 1/2 base times h, and now we're going to say therefore area of triangle is, so we said k is equal to 1/2 base times height. Putting in what I just used becomes k equals 1/2. The base is still going to be b, but now the height is going to be this, right? So the height is going to be a times sine of angle C. And we usually put that alphabetically, so I'm going to reorganize those letters, right? So k equals 1/2, k being area, remember, a b sine of C. And if I do my triangle differently, so let's see what I mean. Let's see, I'm looking at my triangle, and this time I'm going to drop my altitude not from that angle, but let's say from this one, right? It's not quite well drawn, but, and then I would be looking, this is not well drawn at all, but if I have it's really not working out the way I draw it, but what I'm trying to show you is that you can drop your altitude from any vertex, and therefore this can just be rearranged using your different sides and angle, right? So that would also be equal to 1/2 for that same triangle, b times c times sine of a which would also be equal to 1/2 A times C times sine of B. All of those are going to be giving you the area of a triangle depending on what two sides an angle you have. Okay, so that's in the case of side triangle. Now what if what we have is angle side? So find area of angle side triangle. So we're given two angles on one side, and so we're going to have to start with the law of sine. So start with law of sines. So we know the law of sines is going to be A sine angle A equals B sine of B. And we're going to rewrite that isolating B. So we want to isolate B. So that will give me that B is equal to, and I'm going to multiply that sine B to both sides. So I would have A sine angle B over sine angle A. And that's my B. And now I'm going to take that B and I'm going to substitute it in the formula we just came up with, right? So we're going to take this formula and we're going to substitute B in for it, right? So I'm going to have K equals 1/2. I'm on this one, right? That's the one I'm doing. So 1/2 A times, and then I'm substituting this in for B. So A sine angle B over sine angle A. And then times, I still need to do that, times sine angle C. And now I'm going to simplify that. So let me clean up here. I'm going to simplify that, and that will give me that K is equal to 1/2. I have an A times an A, that's going to give me an A squared. And then I have sine B times sine C divided by sine A. Now, this is one form of it. And then just like before, we can rewrite that also as K equals 1/2 B squared. Notice how I have the A here for sine A and then sine A in the denominator, and my two other angle sines are in the numerator. So if I have B here, I will have my sine B in the denominator, and then I would have sine angle A times sine angle C in the numerator. And then the third one, K is equal to 1/2. This time I'm going to have side C squared, and because I have side C here, I want my sine of angle C in the denominator, and in the numerator I'm going to have sine of angle A times sine of angle B. And that will be my third form of it. So again, very basic one that you learned in geometry, 1/2 base times height. When you need to put some trig functions in there, you're going to have a side angle side triangle. You want to rewrite this H as a sine C, and then that's going to become those three formulas. And then if you have an angle side triangle, then you're going to use those three formulas, because angle, right, you will have an angle and an angle on the side, so you're going to put those in there. Okay, now we are going to go into the big one, but I'm going to stop this video, start a new fresh one, because the other one is going to be all on Heron's formula and the proof of it, which is quite involved algebraically. It's heavy duty, not hard algebra, but heavy duty in algebra. So I'll see you in the next video.